Samsung DVM, error code E361 and error code E461. What do the error codes mean, and how do you diagnose the equipment? What's the troubleshooting process look like for those error codes? And how do you replace an inverter board on a Samsung DVM outdoor unit? You're watching HVAC Tips for Technicians. I'm Tad. Let's get started. It's raining, so I brought the tent. So we set the tent up, and you can see we're going to be protected from the rain while we're replacing some inverter boards. So if it's raining and you want to work, make sure you have a tent on site. We're working on this 10-ton outdoor unit. You know it's a 10-ton because it's 120,000 BTU. It's 230 volt, 208, 230, and it's 3-phase. This is the piece of equipment that we're going to be replacing the inverter boards on, and I'm going to show you how I figured out the inverter boards were bad. So I'm going to show you, before we replace them, what I checked. And this is a compressor starting error. That's what it means. I'm going to show you the service manual. This is the service manual for this particular model of unit. How I got this was off Samsung HVAC's website. So samsunghvac.com, go under technical documents, and then you can view the service manual. And then it has the error codes, the description of what that means, the cause of the problem, and then steps you can use to check. So error code E461 has to do with inverter board 1 because there's 2 inverter boards. And then E361 is inverter board 2. There's 2 compressors, 2 inverter boards. And it says the cause could be a compressor connection error or a defective compressor. And it says the way you judge that is if upon startup the speed doesn't increase normally, then it could be your compressor. Here's error 361, error due to operation failure of inverter compressor 2. Then we go to E461, which is right here, error due to operation failure of inverter compressor 1. So E461 is for 1, E361 is for 2. Got the panels taken off. I took off 4 panels total. 1, 2, 3, 4, and then I had a panel behind this panel, and then I had a little panel right here for where the power comes in. Here's my disconnect. Got a 3-phase disconnect. The first thing I checked when I had the error code 361, which was displayed right here, and E461, the first thing I checked was power. So I put my meter on volts AC, and I went from T to S, and you can see from that phase to that phase we got 245, and then T to R 249, and then S to R 246. I wanted to make sure that I had every phase coming into the unit to make sure that I had the proper amount of power. That may throw another code, but it's just something. I start from the beginning. I start with the basics. So I check the power coming in to make sure everything is there. Now, once I verify that we have the correct power, then I shut the disconnect off. And then I check the wiring from each compressor to each inverter board. I've got this inverter board and this inverter board. So we got 2 inverter boards, and the terminals that are black, red, and white, which have the white, black, and red wire, those are the wires that come from the inverter board to each compressor. There's one compressor, there's another compressor. So you take and you disconnect the power, and then you take this cover off, and then you check each terminal. Then you check the wires going all the way up and make sure that you have good connections and that there's nothing wrong with the wiring. That is the second step. Now, before we move forward, I want you to see the error code that I had. So I've got the SNET tool hooked up, and it's hooked up to the F1 and F2 terminal. And I've got it connected. You can see it's connected, and you can see we've got 3 indoor units, 1 outdoor unit. We're going to go up here to where it says controller. We're going to click that button. Then we're going to select all of our indoor units, and we're going to turn them all on. 65 sounds good, or 64 on cooling, fan speeds on high. And then we can go down here and we can see our outdoor unit data. No error codes right now, but you're going to see an error code in a minute. fans kicked on. Inverter boards are blinking. Now I'm going to take my meter and turn it to volts DC while it's running and while we don't have an error code. And then I'm going to go from this top inverter board to the black and red wire. Look what we got down there. 14 volts. Now let's go down here to the black and red wire on the other inverter board, checking the DC. What do we got? 0. So that means from top to bottom, this must be the inverter number 1. And if you follow the wiring, this is compressor number 1 right here. So that's compressor number 1, that's compressor number 2. Inverter board number 1, inverter board number 2. Now, shortly after showing you those inverter boards and which one was 1 and 2, looks like we got an E461. And what did that mean when we looked at the error codes on the front of this cover that covered up this electrical component section? That was compressor inverter number 1. And I'm having error code 461 and 361. So, but if you're just having one of those error codes, then it may just be that you need to check the one compressor. Now, I would definitely go ahead and check both. So what we're going to do now is we're going to take and turn the disconnect off, and we're going to go through and I'm going to show you how to take the covers off and check the compressor windings. Now let's take the covers off of the compressors while we got the disconnect off. Make sure there's no power, and make sure you've waited at least 15 minutes after disconnecting power to even mess with the wiring. So I've got these 3 wires, and I'm going to use a Phillips screwdriver to loosen up the terminals. 1, 2, and 3. And then once that's off, make sure you don't lose the screws. Now that we've disconnected the wiring from that compressor, then we're going to do the same thing to this compressor. So remove the cover, and then we will loosen up these 3 screws. And you don't want to use a drill and a Phillips bit. You want to actually use a Phillips screwdriver. That way you don't over tighten the terminals. Alright, we'll get these wires off, and that one's isolated now. Now we're going to check the windings of the compressor. So we're going to turn the meter to ohms, and then we're going to go from each winding to the next. And since it's 3-phase, they should all be the same. So there is let's make sure we get a good reading. 0.4, 0.4, 0.4. So you saw how I did that? I went from each winding like this, and we got 0.4, and that's less than 2 ohms. Now the second test is we're going to take and go from 1 to the body. Now we're going to check each of the windings to ground. So take your meter, turn it to ohms, and then go from 1 winding to the shell of the compressor. Okay, or you can go to the copper right over here. Let me show you. So you see how we've got a resistance reading, and we've got a resistance reading to every one of the windings. That means this compressor is shorted to ground. Now let's check the other compressor. From each winding to the copper. Wow. Wow. And then the last reading is right there. So both of our compressors are shorted to ground. This is quite unbelievable. But I'm going to be coming back to replace 2 compressors. Yay! It's really hard to believe that these compressors are both shorted to ground. So before I close everything up, I'm going to put these screws in, and I'm going to retest with the screws in. Got the screws back in, meter set to ohms. I got 1 lead touching the shell right here. and we're going to test and see what we got. Wow. Wow. Yep, they are both shorted to ground. Man. Same thing for this compressor. Meter set to ohms. One lead touching the shell. And then let's see what we got. Same thing for this compressor. One lead touching the shell. Got the screws in, and we are going to check. Wow. Swap it. Yep. Last winding. Oh, there we go. Yep, shorted to ground. All right, I'm gonna put it all back together, and then I'll be back with 2 compressors. Today we're replacing some compressors on the Samsung DVM unit right beside me. I've got the panels off. I've got the 2 compressors that we are going to be replacing, and I've got the recovery machine and recovery tank. I really like the fact that inside the Samsung DVM condenser here, or outdoor unit, we've got isolation valves right here. So I'm glad that we've got these service valves. I've got them open and my gauge is connected, but I've also got isolation valves right here. See this? These are isolation valves, and I've got them shut off. So we're going to be pulling the refrigerant out of the system from here and from the outdoor unit, from this short set of line sets and then the outdoor unit. So that's the first thing we're going to do, is pull all the recover all the refrigerant into our recovery tank, and then we are going to proceed to take out the compressors, and then we're going to get some nitrogen set up, and we are going to braze in the new compressors. Then we'll replace the inverter boards. Recovering the refrigerant. And then I'm going to take the compressor blankets off, and we've got a couple connections we've got to take loose, which I'll show you those here in a minute. We are halfway there at 50. All right. Woo! Looks like we're almost there. Yes. Now that we've recovered all of the refrigerant, we can start the process of removing the pipe connections from the old compressor. So I want to show you how to identify each pipe. First, I'm going to show you this thermistor that's on top of each compressor. This is the top thermistor, and this is an overload protection, basically. So we're going to take and remove this before we can remove the compressor. So we got 3 pipes, right? And you can see I've used some sandpaper to sand these, because I'm going to use tubing cutters, and I'm going to cut these 3 pipe connections. This is a discharge pipe. How do we know that? If you follow the line up here, right here, you can see there's a high pressure switch right here. And then if you keep following it, it goes into oil separators. So this is our discharge pipe right here. Then the next pipe, this smaller line, 1/4 inch line, this is our oil return pipe. And if you follow this line down and then back up, it goes to these EVIs, right? These electronic expansion valves. And then they connect to the actual accumulator. So if we have stagnating oil, it'll return that to the compressor if it's in the accumulator. Then we've got our last pipe, which is our larger pipe, and this is our suction pipe. If you follow this line, you're going to see that it goes back into the accumulator. So those are our 3 pipes. I'm going to go ahead and cut those. Top thermistor has been removed. I have cut the discharge pipe and the oil return pipe. Now I've got 1 pipe left, and that is my low pressure pipe, or my suction pipe. So I'm going to keep cutting that. Another way you can identify this line as the discharge line is there should be another sensor on that line. It's right here, and that's the discharge sensor. And that is another 200 kilo ohm sensor. So I'm going to cut this pipe here, and then this compressor will be ready to take out. And then I've got 1 more pipe to cut for this compressor. Same pipe, suction pipe. Let me get those cut, and then we'll work on the next step. Now we're going to use the 1/2 inch socket that I've got connected to the drill, and we are going to take all of these nuts off of the bolts that go through the feet of the compressor. That way we can take this old compressor out. Then we're going to take the new compressors, use our meter, and measure the resistance. That way you can see the difference of a good compressor and a bad compressor. So there it is. Now I'll just need to make sure I get this wire out of the way and I can take this compressor out of here. Removed both of the old compressors. Now we're going to put the new compressors in, and here's the packaging. There's the new compressor. Packaged pretty well. There it is. There it is. It's very good, man. Very good. Yes. Now, to make sure that the new compressor is going to be able to handle the environment, because it hasn't been in this environment before. It's been in a box. You have to tell it everything's going to be okay. Everything is going to be okay. I'm going to put you in here. You're going to work. You're going to work for a long time. And I'm not going to have any issues out of you, okay? All right. I think it understands, and it's ready to go inside. All right. Excuse me, wires. Oh. All right. Looking good. All right, we'll put those nuts on the bolts after I get this one. By the way, I'm sitting on a piece of insulation right now. It is very comfortable. So if you want a comfortable seat, get some Armacell, cut you a 2 foot by 4 foot or a 3 foot by 3 foot piece, or 2 foot by 2 foot, and take it to the job with you. So it'll save your knees, it'll save your butt, and it just helps. Sure. It's in place. All right, now I'm going to put all these nuts on the bolts, secure the compressor, and then we're going to get ready to braze. We're going to get some nitrogen ready. Got all 3 lines connected. There's a lot of space in between this line, so I may need to get a 1/2 inch coupling to put over this and then put it in there, but that's the only one that's like that. A little space around the 1/4 inch, but the 7/8, it's fitting nicely. So I'm going to connect those, and then yeah, you can see that right there, that's not going to work. I need to get something to make that fitting better. Let's turn our meter to ohms. Let's check the new compressor from each winding to ground. And we got no reading, and that's how it should be. Now I'm going to go from the copper to each winding. Okay, so I went from the shell of the compressor to each winding. I went from the copper to each winding. Before we had a reading, now it's open line, open OL. Don't forget to remove the discharge sensor before you braze the discharge line. So, there we go. Forgot to bring the low flow regulator, so I've had to adjust this till I'm just barely pushing anything in. Adding some nitrogen so we can pressure test. Leak testing all the fittings. Make sure I don't have any leaks. I don't think I will, because I made sure of that when I was brazing. but I'm going to make sure I don't have any leaks. And I've already put the wires back on the compressor, put the sensors on top, thermistors, top sensors, and then discharge sensors. I put those back on the discharge pipes. Getting close to being ready to start it back up. We got about 175. I'm gonna let it set for probably at least 30 minutes, maybe even an hour, just to make sure we don't have any leaks. And then we'll put about probably at least 350 psi on this. Releasing all the nitrogen, getting the vacuum pump hooked up, and while I pull a vacuum, I'm going to replace both inverter boards. Got the vacuum pump running, pulling a vacuum. Still pulling a vacuum. Almost below 1,000 microns. Okay. Still pulling a vacuum. Now to get to the inverter boards, we got to take out a few screws. We have to unplug these, and then we have to take out this screw right here, and I've already taken out these two screws. And then there's two tabs, you push them down and you can see how this panel will swing out. Now we take out this screw right here, and once you get that screw out, then you can see this whole panel will swing out. And that's how we're going to be able to get to these inverter boards. Now that that panel's out of the way, you can see we got plenty of room to take our wires off of our inverter boards and get them out of the way. Some advice that will help you to not make a big mistake when you're taking off the wires from the inverter boards: make sure you use a Phillips screwdriver. Don't use a Phillips bit and a drill. You may strip out the head of the screw. Then when you're loosening up these connections on your reactors from the wires that go to your reactors to your inverter board, make sure you hold this right here while you take the screw loose. If you don't, you're liable to break this loose. You don't want to do that. So get something to hold it, maybe a pair of adjustable pliers, maybe some type of clines, and then just sit there and hold it with one hand, and then take your Phillips screwdriver and loosen that screw with the other. Then we've got some plugs that come from our EMI board, both EMI boards to the inverter boards. You want to take and disconnect those plugs. That way you can actually take those inverter boards out. Also, thermal paste. You have to use thermal paste when you're putting the new boards in. Once you remove those screws, then you can just lay this panel down. See how it folds down? That is so cool. Look at these. So cool. Now I got plenty of room. Now when you get the reactors disconnected from the inverter boards, you get the plugs disconnected from the EMI to the inverters, and then you get your wires for your compressors disconnected from those inverter boards. Then we got these screws, 1, 2, and then same thing for this one, 1, 2, and then 1. Well, there's nothing there. So, oh, just one more screw right there. And then we should be able to push this tab and the board will come out. Now, push that tab back and then pull that board and it should slide right out of there. See that? It looks like we've only got one more wire, and it's this plug. So I'll take that loose and this board will be out. Here's that inverter board that we just took out, and here's where the thermal paste has to be installed for those new boards. And here's the next inverter board. All right, let's put the new boards in. I'll show you what thermal paste I'm using. These are the new inverter boards, and these are plastic guards that go around the capacitors, and you'll want to install these on the new inverter board that you're installing. It's very easy to install. It just goes right around here like that. Boom! And then once I get those installed, then we're going to get the thermal paste and start getting these boards prepared. Alright, so here's my thermal paste. Thermal mastic, temperature transfer compound. I'll put a link in the description, so if you guys want to pick some of this up, I keep a large tube, that way I have plenty throughout the year for any of my projects. And here is the box. There are two of these. Pretty sure they're the exact same part number. And there's the part number. All right. Now, I want to make sure we have plenty of thermal paste. Should be able to spread that around. And you can even take it, put it on here like this, just to make sure that you're going to be good, which I think we're going to have plenty. And then I'll spread that around, that way it's nice and smooth. Here were the screws that hold the wires for the reactor and the wires to the compressor on the inverter board, and there's the two screws for the inverter board. I'm almost done smoothing it out. You're not going to see any of that metal when I finish. There's a difference between the screws that hold the wires to the inverter board and the screws that hold the inverter board to the heatsink. These screws are much longer, so make sure you don't mix up the screws, and make sure you don't over tighten these. You do not want to crack the inverter board, okay? One thing you want to make sure you notice is there's a white to blue plug connecting the bottom and top inverter board, and then at the top inverter board we have this plug right here with, looks like a jumped wire. So make sure you have those in place. And now fold this back up. We're ready to start the unit. I'm excited. Compressor blankets back on. And I need to open up these valves. We've got two of them, that's one. And the other one is, I think it's right there. Yeah, I need to open that one up too. Disconnect back on. Using SNET to go through and select all of the indoor units, 2 360 ceiling cassettes and 1 room air conditioner or wall mount air handler. Putting them on cooling, on, turn the temperature down to 65, fan speeds on high. All right. Total outdoor unit 1. Total indoor units 3. Operation modes, compressor down. Error 277. Okay, that means low pressure, I'm pretty sure. So we should have pressure now. We got pressure, yeah. Okay, so we shouldn't have that error code now. Oh wait, we do have an error code. Error code 277. It looks like we got an error code E277. And if we look right here, that means error on top sensor of compressor 2, short or open. So if we go over here and look at our outdoor unit data, we can see compressor 1 top's 81 degrees. That's right. Compressor 2 top, negative 40 degrees. I wonder if we cut a wire or something, or we don't have it plugged in correctly. So one of those sensors on one of the tops, let's check it out. The wire got cut. Wow. Be careful, because a simple job can turn into a nightmare, and obviously I wasn't careful enough and I cut the wire going to the sensor. Yay! I've got a 200 kilo ohm sensor that I had in my parts room that I didn't use, so I'm splicing it in place. That way I can get the system back online and cooling, and then I'll order the sensor that is required for this equipment, and then when I get it in, I'll take this sensor out. Connected to SNET. I'm going to go back up here to the controller, Select all 3 indoor units, and then on cooling, turn the temperature down to 65, and then exit. Operation status cool. Operation mode was stop. You just seen it change to safety start. Still not displaying those top sensors for the compressor, but looks like they're about to, yep, so now they're reading correctly, 76 and 77. I'm so excited. All right. Oh wow, fans are coming on. Yes. All right, so now we can dial in the charge. Room temperatures are pretty hot, 83, 84. Those numbers are far apart, 42 and 70. So we need to make those, the evaporator in and out temperatures closer together. So we need to add some refrigerant. Suction line temperature 77, wow. Yeah, you can definitely add. The low side is 120, high side's 300, let's add. After adding some refrigerant, low pressure's 120, high pressure's 320, suction line temperature 64, and then, oh yeah, 45, 47, 49, 67. That is much better. EEV valves are opening up a little bit. I'd say we are close to charged. All right. If you like this video and you want another video learning about these Samsung DVM units, I'm going to put a couple videos and a link in the description so you can go check those out and learn more, because I've had other experiences working on this type of equipment. I did have a good experience with this. I learned some things. I learned that you need to be careful when you're removing or replacing these thermistors. I ended up removing the top thermistor on top of the compressors and ended up damaging it. I did not know they were so easy to damage, and because of this, I've had to install a temporary sensor until I can get the original sensor. So I learned that. I also learned that I may need to check with 2 meters instead of 1. I may need to have a backup. That way I make sure that I get the right reading the first time. If you've ever had a reading change, let me know. Let me know what the experience was like. For me, checking the compressors and then calling tech support and ordering the inverter boards, then going back to the job and then checking the compressor again and it's shorted to ground was very unusual. So I ended up replacing the compressors because of that. Now the job is successful, it's operating, but I have not had that happen. So let me know if you've had that happen where you had a couple different readings, or maybe you use 1 meter and maybe it wasn't working correctly and you had to use another meter. So I'd love to know what your experience is. If you like the video, hit the like button, subscribe, and smash that bell ding so you know what I'm doing. If you want more videos like this, go check out my playlist, HVAC Tips for Technicians. If you got a question, please ask me the question, because questions can lead to new content. But if you don't have a question, that's okay. Let me know who you are and let me know where you're from. I like to know where all my viewers are from. Another thing that I may have covered in this video, but I want to reiterate it. When initially I had the error code E361 and E461, in the service manual through the steps it says to check the bypass valve. Now on this heat pump there's one bypass valve and it's a 230 volt valve. And that valve is there to protect the compressor. That valve is there whenever you experience an abnormally low pressure or high pressure, then that valve will open. And that will help to normalize the pressures for operation. So that's like a compressor protection device there. But it did not have anything to do with error code E361 or E461. So I don't know why it was in that particular service manual under that error code. So I want you to know that that's most likely not going to be the problem if you have this error code. It's probably going to be either your compressor or your inverter board. Another thing is you would think that if it was shorted to ground, it would trip the breaker. But for this 3-phase particular compressor, it is not going to trip the breaker. Now, it may burn up one of the boards. It may burn one of the fuses in one of the boards, but it's not going to trip the breaker. So I want you to know that as well in today's video. You've been watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.